Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The alkene shown is trans 2-butene, E2-butene, where H3C and CH3 are on opposite sides of the double bond, with H atoms on each sp2 carbon. Moving on to the next step. OSO4 performs a SYN-CIS addition of two OH groups across the double bond. Both hydroxyl groups are added to the same phase of the alkene simultaneously via a cyclic osmate ester intermediate. Moving on to the next step. In trans 2-butene, the two methyl groups are on opposite faces. When OSO4 adds both OH groups SYN, same phase, the two OH groups end up on the same phase. For trans 2-butene, SYN addition from either phase gives the same product due to the geometry. Both OH groups add to the same phase, but because the methyl groups are trans to each other, the resulting diol has OH groups on the same side in the transition state. This gives the RS is equal to meso compound, compound 1 in Fischer projection, both OH groups on the same side, i.e., HO and HO both pointing right. And for the final step. For trans 2-butene plus OSO4, SYN dihydroxylthione SYN addition from top phase gives 2R, 3S, and SYN addition from bottom phase gives 2S, 3R, but for trans 2-butene these two are identical, they are the meso compound, since the molecule has an internal plane of symmetry. Therefore only the mesodiol, compound 1, is formed. Options 2 and 3 represent the R, R and S, S enantiomers, the trio-antidiol, which would result from anti-addition, not SYN addition by OSO4. Option B, 1,1 mixture of 2 and 3 would be the result of anti-addition to trans 2-butene, like epoxidation followed by ring opening. Option D is incorrect because OSO4 gives exclusively SYN addition. Option C, only 2 is incorrect. Therefore, the correct answer is A. Therefore, the correct answer is option A.